Alright guys, we have a question today. A question about inverse trig functions. Here we are trying to find the tangent line to the curve arc secant 6x at this point. Now we are in section 3.6. This is number 12 for your homework. So we're working with inverse trig functions, but the process to find the equation of the tangent line is the exact same it has been all of chapter 3. So here are those general steps. The general steps are to find the derivative, we'll say in this case y prime, and then step 2 is to evaluate the derivative, so y prime at the point. Okay, so that's step 2. Step 3 is to write the equation, use point slope form to write the equation of the line. Okay, so of course now we have a new derivative we're working with, but we're going to follow that same 3-step process. Oh, actually I should say it's a 4-step process, because we're usually going to write write final solution in slope-intercept form. So about 4 steps there. These are the same 4 steps we have been using all of chapter 3 since we started talking about derivatives. Okay, so let's see here. First thing we have to do is we have to remember what the derivative of arc secant is. Now, in general, the derivative of arc secant, u, so of some function u, is u prime divided by the absolute value of u times the square root of u squared minus 1. So that's something we need to have memorized, especially if we have a test coming up. We need to have that memorized. Arc secant, arc cosecant, arc tan, arc cotan, arc sine, and arc cosine. Remember those are paired up. So for instance, arc cosecant is just like this, except there's a negative sign up top. Okay, so just make sure it's not as bad as it seems to memorize those 6 new derivatives, because if you just memorize the fact that arc sine and arc cosine are paired together, arc tan and arc cotan are paired together, and arc secant and arc cosecant are paired together, those you really only have to memorize three new things. So let's take a look at this. Let's use our new inverse derivative rule here, and we can say that y prime in this specific case, y prime equals, okay, we have a big fraction here, it's u prime, so the derivative of 6x. The derivative of 6x is just 6. But then we divide by the absolute value of 6x times 6x squared minus 1. Okay? And that is the derivative. There's not really a whole lot of simplification we can do. We could, I guess, there's one little step. We could say, for instance, that this is 6 over the absolute value of 6x divided by, the only thing we can really do is say 36x squared minus 1. That's about all we can do there. Okay? Now, that is the derivative, that's y prime, but we're not after, that's not all we're after here. We need to evaluate, by step 2, evaluate y prime at the given point. Okay? Now, this function was explicitly defined, so the derivative has only x's in there, so we only need to evaluate the derivative at the x term, root 2 over 6. So step 2 is we need to evaluate at our point. So let's see here. I'll put step 2 right here. So y prime at x equals root 2 over 6. Now what do we get here? Okay, so we get 6 divided by the absolute value of 6 times root 2 over 6. So I guess I need maybe bigger absolute value signs. Maybe let's straighten those up a little bit. 6 times root 2 over 6. Alright, times the square root of, 36 times the square root of 2 over 6 squared minus 1. Okay, so we get 6 divided by, now the square root of 2 over 6 times 6 just leaves us with the square root of 2, or the absolute value of the square root of 2. But what's the absolute value of the square root of 2? The absolute value of the square root of 2, that's a positive number, so that's just square root of 2. Okay? Now let's see what happens in this radical here. So you have the square root of 2 squared over 6 squared by our rules of exponents. So that's 2 over 36. So 2 over 36 times 36 is just 2 minus 1. So the square root of 2 minus 1 is clearly 1. So what we get here is 6 over the square root of 2. Now, of course, that's not in proper form. It has a radical on the denominator. So we want to rationalize the denominator. And so we can say that this is equal to what? 6 square roots of 2 over 2 by rationalizing the denominator, which gives us 3 square roots of 2. So that is our slope. 3 square roots of 2. That's the slope of the tangent line at that point right there. Okay? Now I'll move on to step 3. Step 3 says to use point slope form to write the equation of the line. Okay, so step 3 over here, we have this point right here. And we have this slope down here. So point slope form says y minus y1. So y minus y1 is pi over 4. So y minus pi over 4 equals m, which is 3 square roots of 2, times x minus x1, which is root 2 over 6. Okay, so that is the equation of the line. But we're never going to be allowed to leave it in this form. Okay, we have to simplify, and step 4 says to write the equation of the line, the final solution, in slope-intercept form. That means solve it for y. Okay, so to solve this for y, I distribute the right-hand side and add pi over 4 to both sides. So I could say y equals 3 square roots of 2 times x. Let's see here. Now, if I distribute here, I'll have 3 square roots of 2 times the square root of 2 over 6. So that gives me 3 times 2 over 6. Oh, so let's see here. That's 3 times 2, which is 6 over 6. Sure, that's 6 over 6 is 1. So that is minus 1 plus pi over 4. Okay? So 3 halves, not 3 halves, 3 square roots of 2, okay? 3 square roots of 2, x minus 1 plus pi over 4. Okay, let's maybe double check all that. Are we good here? Let's see here. Yeah, I think we're good. Okay, now one thing you could do here, I suppose, you could get a common denominator if you really wanted to. We could say that that is y equals 3 square roots of 2 x. Now that would be a common denominator would be 4, so it would be minus 4. Let's see, so it would be plus, actually we'll do this, it'll be plus minus 4 plus pi over 4. So technically what we have here is we have a slope, and there is our y-intercept, negative 4 plus pi over 4. Okay, so that will give us our tangent line to this curve right here at that point. Okay, so yeah, it's the issue here is that we have to first remember the derivative. Once we remember the derivative, there's a little bit of simplification involved, not a whole lot, but there's a little bit of algebra right here. But once we get the slope, it's not too bad, but there is a little bit of algebra here. So just be careful with your arithmetic and your algebra, and you should come out just fine. So here we are, right here, final solution. Y equals 3 root 2x plus negative 4 plus pi, all divided by 4. So, hope this helps. If you have any questions, please feel free to ask, and talk to you soon.